Hey everybody, we're on 10.4, missing sides and solving triangles. So in our last lesson we talked about missing angles and we used inverse trig to find those angles. Today we're going to be talking about missing sides, and we kind of talked a little bit about missing sides when we did 10.2. Okay, so we kind of did problems like this. So it says find the missing side of each right triangle. You notice that all of these, or these two examples, two of the sides are given and we need to find the third. So when you have two sides of a triangle and you can find the missing side by using what? Well, that is the Pythagorean theorem. Okay? And again, that's your a squared plus b squared equals c squared, where c is always your hypotenuse. Okay? All right, so we can do a couple of these if you'd like. Pause and give this a try. I'm going to try and go through this a little quick and spend more time on the newer stuff. So here we could say this be our a. So we could do a squared plus 4 squared is equal to 9 squared. All right, we could... or maybe I'll move this over here. Give me a little more room. Okay, so 4 squared, well that's 16, and that's 81. We could subtract the 16 from both sides. We get a squared is equal to 65. And then we can get a by itself by square rooting both sides, and we get the square root of 65. And that cannot be reduced, if I am correct. Yes, because it would be 5 and 13. Yeah. Okay. All right. Here's another example. Maybe this one's a little different because we have like a root. So this is a good example to go over again. So we could say like this is your a, b, and c. So we got 5 square roots of 2, and we're going to square that. So make sure you put a parenthesis, especially if you're going to use a calculator. And we'll do plus 9 squared is equal to x squared, or c squared, I guess we could call it c. All right, so if we do square the first term, that would give us 25 times 2, so that would be 50. And 9 squared is 81. Combine like terms, that's 131. And then we could square root both sides, and we get c is equal to square root of 131. All right? So that's nice when we have 2 of the 3 sides. But what happens if we have something like this where we are missing a side? So all of these problems we're going to be covering is where we have one side given, and we have a reference angle, and we know the degree for that, and we need to find its missing side. All right? So let's recap what are the trig ratios. For sine, it is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay? So let's just see what we can come up with. Again, please make sure that your calculator is set up in degree mode. For like a TI, let me just pull that up. I'll show that again from the last video in case you missed it. Sorry. I don't know. There we go. Okay, so if you're on your main screen, you want to click on mode, which is like straight over there. And then you'll go down, and mine is set up on degrees or radians, so I need to push over and then push enter, and it will change it to degrees. And then once you calculate stuff, it'll be in degrees. So make sure you have that set up. A good way to check that is you could do sine of 30, and that should be equal to 1/2 or 0.5. All right, so let's do some problems and see what we can come up with. Oops. All right, so here, again, we're going to do the same sort of setup. We're going to look at our reference angle, and we need to identify our sides. So here we have opposite, here is hypotenuse, You could write down adjacent, but we don't have that information. All right? So which trig ratio uses opposite and hypotenuse? Well, that's sine. That's our so. So sine of theta, and this time we know what theta is. Theta is 49 degrees. And that's equal to opposite x over hypotenuse, which is 14. So now we need to solve for x. Okay, so we need to get rid of that 14, and it's being divided by, so what's the opposite of division? Well, that would be multiplication. So we need to multiply both sides by 14. 14s would cancel, and we would get our answer, which is x equals 14 sine of 49. Okay, and then again, we're probably going to be rounding, so we need to write it down as approximately. So x is approximately equal to 10.57. Okay, and if units are given, then we should write units. But I think for all of these, it's just there's no units. Okay. All right, why don't we do this one? I'll get my calculator out and make sure you're good with that. All right, so here's our reference angle. We have our opposite, and we have our hypotenuse. So again, we're going to be using sine. So sine of 21 is equal to x over hypotenuse, which is 14. Is that the same problem? No, it's not. The degree is different. I always look at that. It's like, what? All right, so again, to get the x by itself, we need to multiply both sides by 14. And then we can just say x is approximately equal to, here, let me grab this out, see if this will work. Hope this works. Okay. Okay. Let's try this real quick. So sine of 30 should give us 1/2. Okay, good. So we'll plug in 14 sine. You don't need to, it'll automatically multiply them together. You don't need to write multiplied. And then we'll do, 21. And I get 5.02 if I round to the hundredths place. All right. Okay, let's do this one. Oops, I can't get that over. I need to move that over. Okay. Pause and give a try on any of these. It will help you the most. Okay, so here we have our opposite and adjacent this time. So that's TOA. So, oops, forget that. So tangent of 38 is equal to opposite over adjacent. Okay, so again, we need to get x by itself, so we could do 12.9 on both sides. We can plug this into our calculator, 12.9 tangent of 38. And I get 10.08. So x is approximately equal to 10.08. All right. So go away. Go away. Go away. Oh. All right, there we go. Okay, we're going to go through these ones a little quicker, so we have time to talk about solving triangles. So here we have our reference angle. We have opposite and adjacent. So again, we're going to do tangent. So tangent of 38 is equal to opposite over adjacent. Okay, so looking at this, it's a little different. To get x by itself, it's going to take us 2 steps. So to get it by itself, we'd need to multiply both sides by x. So we get x tangent of 38 is equal to 5. And now to get x by itself, we would need to divide both sides by the tangent of 38. Okay, and we would get x is equal to, and that's what we'll plug into our calculator, and would get 6.40. Okay, so Takes 2 steps if x is in the denominator. Let's do one more like that, or pause and give this a try. So we have opposite and hypotenuse, that's sine. So sine of 59 is equal to opposite over hypotenuse. So again, we'd need to multiply both sides by x, and then we would need to divide both sides by the sine of 59. So we'd end up getting x is equal to 19 over sine of 59. And we'd get x is approximately equal to, where did I put that one? 22.17. Okay? You may notice that there's like a kind of like, well, I don't know, we don't talk about that. Okay, so last one, again, reference angle. We have adjacent and hypotenuse. So what unit would we, or what trig ratio will we use? That would be cosine, so that's ca. So cosine of 51 is equal to adjacent over hypotenuse. Again, we need to multiply both sides by x. And then we need to divide both sides by cosine of 51. So basically we have x is equal to 11 divided by cosine of 51. So x is approximately equal to 17.48. Okay, so let's just recap real quick. If we're missing a side, we still need to label our sides based off of its reference angle. We'll need to figure out which trig uses that reference angle, whether it be ca, or toa, sine, cosine, or tangent. And then we'll just need to, one of our sides will be x, and we need to solve for that. If x is on the top, we just need to multiply both sides by the denominator. And if x is on the bottom, let's do a better example of that, okay? Then we'll need to do it twice. We'll need to multiply both sides by the denominator. That will get the x in the numerator. And then we'll need to divide both sides by sine, cosine, or tangent. All right? All right, let's talk about solving triangles. Maybe we'll do one, and just to keep the video a little shorter, I'll just write the answers for the other so you can practice on that. Or maybe I'll do the whole thing, but you can just skip the speed, go faster, okay? All right, so solving a triangle means that we need to find, not mind, find the measure of every angle and side. Typically, they will always give us half of that information. All right, so for example, this problem, they already give us side CD, so that's 18. They tell us angle E, measure of angle E is 27 degrees. And they also tell us that angle C is 90 degrees. So we just need to use some trig. You could even use the Pythagorean theorem, or you can use, if we have two of the three angles, we could use all the angles of a triangle add up to 180. So those are kind of like your tools to be able to solve these triangles. All right, so I'm going to start by trying to figure out what side CE is. So I'm going to call that X, and we're going to solve for that. All right, so I'm going to use trig, and we have this reference angle, which means that this is our opposite, and this is our adjacent. So if we want to figure out what X is, we'll need to use what uses opposite and adjacent. Well, that would be tangent. Okay, so tangent of 27 is equal to opposite over adjacent. And we'll need to do what we just did above, solve for X. So we could multiply both sides by X. and then we'll need to divide both sides by tangent of 27, and would get 18 over tangent of 27. Okay. We plug that into your calculator, I think we get 35.33 approximately. So we have CA, or CE, is 35.33 meters. Okay, we could find the hypotenuse the same sort of way. Okay, I'm going to use trig again to find the hypotenuse. So this is our hypotenuse. I'll call it y for the length. So here we're going to do opposite over hypotenuse. So that would be sine. So sine of 27 is equal to opposite over hypotenuse. I'll call that y. It's always a really good idea when we're trying to solve a missing side is to always use the side that's given. Because if you were to use this side to solve, you're rounding, which means we'll round again, and you'll just propagate that error when we round. So always use the sides that are given as much as we can. All right, so again, we need to solve for y. We'll do it the same sort of way, and we'll end up getting y equals 18 over sine of 27. And that will give us 39.65. So 39.65. All right, so we found those two sides that are missing. So maybe I'll write those down on the sides. So we figured out 39.65 meters, and we figured out that this is 35.33 meters. Okay, now we just need to find our missing side, or angle, all right? So the easiest way, since we already have two of the three angles, we could do 180 minus 90 minus 27, and that would give us 63 degrees. All right, so that is solving a triangle. Again, it's just building in everything that we've used so far. Here's B. I'll go ahead and do this. If you feel like you're comfortable or just want to practice it and then go to the end, that's great. So we have JK is 2 square roots of 3. And we have the hypotenuse, which is KL, which is 8. And we need to find JL. Okay? So we need to figure out what that is. And they also tell us the angle J is 90 degrees. So we could say this is 90 degrees. All right, so where to start? Well, I'm going to start by trying to figure out what angle K is. So if we're going to use that, that's our reference angle. And this would mean that this would be our opposite. This would be our adjacent. And this would be our hypotenuse. So we have the adjacent and the hypotenuse, so that would be ka. So kata would use cosine. So cosine of theta, or cosine of k, is equal to adjacent, so 2 square roots of 3 over the hypotenuse, which is 8. Again, we need to solve for theta, so we'd do theta is equal to cosine inverse. And to get the cosine away, we'd use cosine inverse of both sides. Cosine inverse and cosine cancel. So we'd do cosine inverse of 2 square roots of 3 over 8. And that would end up giving us 64.34 degrees. So 64.34 degrees. All right. We need to figure out what angle L is. Well, again, we could do 180 minus 90 minus 64.34 degrees, and that gives us 25.66. And, I mean, you don't need to use that way. You could use trig again, and you could use this as your reference angle, and you could solve for that angle. All right, so now we have the two missing angles, and we need to find the side. So you could use Pythagorean theorem, or you could use trig some more. Again, since we don't know these angles exactly, it might be nice to use the Pythagorean theorem so we have an exact answer. All right, so again, if we use our Pythagorean theorem, we would do something like a squared plus b squared plus or equals c squared, where c has to be your hypotenuse. So we could do 2 square roots of 3 squared plus b squared is equal to 8 squared. And we just need to reduce all of this, or evaluate the 2 square roots of 3 squared. That would give us 12 plus b squared is equal to 64. Subtract 12 on both sides, we'd get 52. And we get b equals the square root of 52, which we can reduce. 2 goes into 52 26 times, and 2 goes into 26 13 times. So here we have a group of 2 that we can take out, so we'd get b equals 2 square roots of 13. So that would be our exact answer. All right, well, if you have any questions, let me know. I'm here for you if you have any questions.